All right. 7.5, applying trig ratios, part 2. All right, so like I was saying, they're just a little bit more difficult now, right? There's just more pieces involved, but really we can just jump right straight into some questions here and do this one. So question 1 says, calculate the length of xy to the nearest tenth of a centimeter. So xy is looking for that length, right? So quite often with these problems, you'll see that there's going to be 2 or more triangles, right? There's a triangle there, and there's a triangle there, right? And those triangles will share something. They have something in common, right? So if you can see, if I was looking for this one right there, that length, I've only got one thing so far, right? I've only got that this is 22 degrees. And to solve any of these right angle triangles, you can pretty much you can solve like it entirely, but you always need 2 things to get going. You can't start with one thing, right? So quite often there's going to be something that they share. And what they share in this case is going to be this side length, right? That's going to be the side length for that triangle and that triangle. So if I use the information from this triangle and solve this one, then I'm going to have my piece for the next one, right? So that's kind of the idea there. So let's do that. Just using SOHCAHTOA. So I'll write down SOHCAHTOA again. All right, so SOHCAHTOA. I'm looking at this angle and I'm looking for this side. Let's call that X for a second. All right, so what do we have? Well, we have the hypotenuse and we're looking for the opposite, the one on the other side there. So which of these has hypotenuse and opposite? Well, that's sine. So that's what we're going to do. We're going to say sine of 20 degrees is equal to, and then opposite over hypotenuse, that would be x over 8.4. Okay, and then just bringing the 8.4 up here, or like multiplying both sides by 8.4, we get 8.4, come on, times sine 20 degrees is equal to x. All right, so let's put that in. So we get, I'm going to try this out and see if I can use my calculator on screen. No, maybe not. All right, let's try this. We got 8.4 times sine 20. So we get 8.87 yada, yada, yada. So 8.9. I'll keep the digits though, just because we're going to use that again. So we'll say 2.873. Okay, so that's what that side length is. So that was part 1. All right, part 2. Now that we know this, right? Now that we know that this side length here is this, well, now we have 2 pieces of our triangle and we're going to solve for the hypotenuse. So in that case, right, so here this was 2.9 or that number there, right? So we'll say, okay, if you're looking at that one, then we have the adjacent side, right? That's the adjacent side of this triangle. And we're looking for the hypotenuse. All right, so which of these are we going to use? Well, this time it's cos. So we'll say cosine 22 degrees is equal to, and then cosine is adjacent over hypotenuse. So that's going to be 2.9 over, call that maybe y, just so it's a different variable than last time. You could call it xy too. I just usually like to just use a single variable. Okay, rearranging this guy, you guys should probably be okay at this by now. I'm going to skip to the gist of it. I'm going to go, y is going to go up, cos 22 is going to go down. So we're going to have y is equal to 2.9 over cos 22. Okay, so 2.9 divided by cos 22. It's equal to, 3.1. So 3.1, and then that was in centimeters. So that was angle, or side length, xy. All right, next one.
Brown, can you let Marley into the class? She
Yeah, I just
said
did.
she's stuck in the waiting room.
Yeah, I just did. She's coming in.
Okay.
All right. A surveyor stands at a window on the 9th floor of an office tower. He uses a clinometer to measure the angles of elevation and depression of the top and the base of a taller building. The surveyor sketches this plan of his measurements. Determine the height of the taller building to the nearest 1/10 of a meter. Okay, so we need to figure out the height of this guy. And he has told us, and by the way, too, I want to make sure you guys see this because there's just like one vocab in this unit that screws everybody up. Angle of elevation and angle of depression. So if you were looking right here, then angle of elevation would be the angle, if you drew a straight line out from where you were at, it'd be the angle going up. That's your angle of elevation. And then angle of depression would be the one going down, right? So that'd be the 42, and it's from the line straight out and then down. This one's fine because they gave us the numbers in the picture, right? But if you had a question where it was like a word problem and you weren't given the picture, you'd have to know how to draw that picture, right? All right. So we are after the height of this building. And so really, I'm looking for, this length, and I can add them together, right? And we have a little bit of a hint here. It's 39 meters to where he's looking out the smaller building here, right? Well, that means that you could say, okay, if this is 39 meters, then this would also be 39 meters. So if I want the height of this building, well, I'm already halfway there, right? This is 39. I just got to find this side now. So again, there's something that these two triangles that you can see there have in common. They have this one in common, right? They have that length right there in common. So what we're going to do, we're going to use the bottom triangle to solve for this side here. And then we're going to be able to use that because then we'll have two things to solve for the backside and then add them together. Okay, so let's call that length here, call it y. So that we'll look for y first. Okay, so if I'm looking for y there, according to SOHCAHTOA, then we have the opposite side, and we're looking for the adjacent. So that's tan. So we'll say tan of 42 degrees is equal to 39 over y. Rearranging that with the way you guys should be used to by now, you'd say y is equal to 39 over tan 42. All right. So we'll say 39 divided by tan 42. And that is 43.314. Oh, shoot. 43.314. Okay. And then meters, right? And I'm going to use that again in a second here, okay? Now we're going to use that number, right? So we're going to use that number because we know that now to solve for the backside there. So this time we're going to use, we have the adjacent, right? We know what y is now, and we're looking for the opposite. So again, that's going to be tan. So we'll say tan 31 degrees is equal to, and then the opposite was x over, and then the number that we just found there, right? At 43.314. So bringing that up, that would be 43.314 times tan 31 degrees is equal to x. Okay, so it's going to be that. Can I copy this? Might not work out as well as I thought it would. No, here, I'm gonna use my calculator on my phone. $43.314 times 10, 31. And we get, my calculator's in radians. Sorry, guys.
I like how you laugh at that, Brown, and we're all just like sitting here. Must be a math teacher thing.
Laughing at yourself for being in radio.
Yeah.
You end up with 26.0. So 26. Actually, you know what? I'm going to keep a few digits because we're going to add this up. So 26.026 meters. Okay. And then really in the end, right, it's just adding these two together. So I'll even just do this. I'll say plus, right? We're just going to add that one and that one. And that's going to be equal to. This isn't the proper math way to write it, by the way. All right, so plus 43.314. So we end up with 69.3 meters. So in the end there, yeah, we would really just say, so it does say 1/10 of a meter. Okay, so yeah, 69.3 meters. All right. Two more. Okay, so this one says from the top of a 90-foot observation tower, a fire ranger observes one fire due west of the tower at an angle of depression of 5 degrees, and another fire due south of the tower at an angle of depression of 2 degrees. And it says, how far apart are the fires to the nearest foot? All right, so they are looking for this distance from here to here. Okay. Now, it's a little bit hard. These ones are a little bit tougher because it's in 3 dimensions. You have to kind of be able to picture what's going on there. But you can see if this was the one to the west, this one over here, then this would be a 90-degree angle going up, right? This is like all the way to the base tower and then up again. So that'd be a 90-degree angle. And then, yeah, they've drawn in that would be 5 degrees, right? Now, if we're looking for this length here, what I can kind of see is that this would also be a 90-degree angle here. So if I could just figure out this length and this length, if you know two sides of a right angle triangle, you should be able to do Pythagorean theorem, right? To find that length there. So those are going to be the two pieces we have to find first. We're going to have to find this side, maybe I'll call that Y, and this side, I'll call that X. Okay? So we'll find those two first, and then we're going to use those to find the hypotenuse of that other one. Okay? So what do we know? Well, they said this was 5 degrees. You see that's kind of like outside of the triangle, though? Like at the one I'm looking at? Like I'm kind of looking at this one right now, right? That triangle there. Well, I can use that 5 degrees, though, to say, well, okay, that one there, this must be 90 degrees straight out. And it's hard to see because I know that's not 90 degrees on your page, but it would be in real life, right? So that's 90 degrees. So then this must be 85 degrees, even though it doesn't look like it, right? It's not the scale. Doesn't look like that at all. But okay, but that's 85 degrees. And we also know the height of this tower. The height of the tower was 90 feet. Right? So that'd be 90 feet. Or 90 degrees, 90 feet. I was right, 90. Okay, so we know two things. We can solve this one. So let's solve for that side there. So if I'm looking at the 85, then that would make the red side there the opposite. And the 90 would be my adjacent. So I have opposite and adjacent. That's tan. Use a different color. So that's going to be tan, 85 degrees is equal to, and then the opposite is what I'm looking for. That's the Y over 90. So bringing the 90 up, we end up with 90 times 10, 85 degrees. So 90 times 10, 85. So we end up with 1,028.705 feet. Okay, I'm going to put a box around that because I'm going to use that in a second. All right, now let's do the other one. So pretty much the same thing, but now we're going to be using the other angle, right? So now in this case, this angle of depression was 2, So in that case, this is going to be 88, right? That'd be an 88-degree angle in there for that one. Okay, so we're going to do the same thing, but it'll be now instead of 85, it's going to be tan of 88 degrees is equal to, and then X.
Mr. Brown, 85 plus 2 does not equal 88.
No, that 80, that what that comes from here is that this is 2 degrees, right? And I know that this would be 90 degrees from there to there. So I'm going 90 minus 2.
Oh, okay. I was like, that makes no sense.
Right. Yeah, it's getting a little crowded in there. It's this angle right here. That would be 88 degrees.
Okay.
Yeah, if that one's 2. Yeah. And it's hard to see, like I said, because this doesn't actually look like 90 degrees, but it would be in real life, right? If you're thinking in 3 dimensions there.
Yeah.
Yeah. Okay. So now, so everything's the same now. It was 85 and now it's 88. Okay. What was I doing there? Oh, yeah, it's equal to opposite over adjacent. So now the X is the opposite, right? That's the opposite side, and your adjacent is 90. Okay, writing it out again, we get 90 times tan 88 is equal to X. So that would be, so we get 2,577, and I'll leave a few more digits so we're accurate. 263 feet. It's equal to X. Oh, it's equal to X. Okay, almost there. So now, very last thing is that this length from here to here, right? That's what we're after. And now we know the 2 sides, right? The one side was this one, right? That's going to be the red side there. And then this one was that side. So we know 2 of them. So this is just a squared plus b squared is equal to c squared. A squared plus b squared is equal to c squared. So we've got, we'll say c squared is equal to, we'll make that c so it's the same. C squared is equal to 1028.705 squared plus 2,577.263 squared. So then I'm gonna I'm not gonna write it all out again. I think you guys will be all right with this. I'm just gonna cut to the gist and say, okay, C, you would take the square root of everything, right? And I'm actually gonna use the calculator or the numbers in my calculator as well, just so I'm the most accurate I can be. That squared plus that squared. So we end up with C is equal to 2,774.98. And I think it said I wanted it to the nearest foot, right? So we'll just round that up. So we get C is equal to 2,775 feet. Okay. And you know what? I might even just call that it, because this one is like exactly the same. It's like the same question. This time though, they've just given us these angles instead of the ones above, but everything's the same. They want us to find how far apart these 2 people are. So it'd be like the same question. So you know what? I'm not really going to do that one. It'd be great if you guys did do that one and see if you get an answer that seems to make sense. And then, yeah, when you guys are done that, it's on to the assignment questions.